For number 11, the graph models the baseball schedule for a week. The vertices represent the teams. Each game played is represented as an edge between two teams. So if you look at this graph, imagine this graph is positioned on top of a map of the United States and Canada. Would Pittsburgh be in the correct geographical location? No. Chicago? No. Chicago's closer than Pittsburgh might be, but they're not. They're not in the correct geographical location. So the second question, if the positions of Chicago and Pittsburgh do not correspond to their geographic locations, is the graph drawn incorrectly? Well, the answer to that is no. So what we're interested in, the vertices, in this case, they represent baseball teams. And we want the edges to be correct to show the correct relationship between the teams, whether or not they have a game in that week. So I've pulled up this Blitzer bonus. On this right here, they're talking about the subway system in London. The subway system is as sprawling as the city it serves. Who in here has been to London? I cannot raise my hand on that one, but so if you've been to London, did you ride the subway system? All right. So the original map, or one of the earlier maps, let's not say necessarily original, it was more in line with having things in their correct geographical location. So in 1931, a draftsman, Henry Beck, found a solution to making the map easier to read using graph theory. If you're on the subway, you need to know how to get from point A to point B. And using a map where the subway stops are not in their correct geographical location, they're just kind of showing where the trains go, is much easier to read than one that would show their correct geographical location. So here's an example of where graph theory was used to make something much simpler to read.